Hello, I'm Michael Brown, and in collaboration with colleagues located across the globe, I have built a new atlas of 129 galaxy spectra spanning from the ultraviolet through visible wavelengths and into the mid-infrared. Our atlas contains more galaxies, spans a broader wavelength range, and has smaller random and systematic errors than the prior literature. Our work is published in the Astrophysical Journal Supplement series. When we look at distant galaxies, the expansion of the universe results in light being stretched to redder wavelengths. As a consequence, to determine the luminosity of a galaxy at a particular wavelength, we need to model that galaxy's spectrum. The expansion of the universe also results in observed galaxy colours being a function of their distance. Consequently, models or templates of galaxy spectra can be used to approximate distances using observed galaxy colours. All of the galaxies in our atlas have imaging between 0.2 and 24 microns wavelength using data from GALEX, SWIFT, Sloan, 2MASS, WISE and Spitzer Space Telescope. All of the galaxies in this sample also have optical spectroscopy, and the vast majority also have Spitzer IRS spectroscopy in the mid-infrared. Many of our galaxies have Akari infrared spectroscopy too. The gaps in our spectral coverage have been filled using MagPhys models constrained with our photometry. And to connect all input datasets together, we have measured matched aperture photometry for each galaxy across our entire wavelength range. Our photometric aperture size was matched to the optical spectrum extraction aperture, and we then scaled the spectra at other wavelengths to match our photometry. This includes dealing with wavelength-dependent effects, which can be significant for Spitzer spectra. The redundancy in our data, including ultraviolet imaging from both GALEX and SWIFT, and mid-infrared imaging from both Spitzer and WISE, has allowed us to mitigate a series of systematic errors in our data. NGC 3079 is one of the galaxies in our sample, and this plot shows a spectrum of NGC 3079 with flux on the y-axis and wavelength on the x-axis. The dots denote photometry used to constrain and verify the spectrum. We can see nebular emission lines at 0.5 microns wavelength and emission attributed to PAHs and dust in the mid-infrared. NGC 1275 is a well-known brightest cluster galaxy that is also in our sample. Again, we see emission lines at optical wavelengths, and in the mid-infrared we see hot dust emission. One way of evaluating the performance of our entire atlas is to compare colours synthesised from our spectra with the observed colours of galaxies from other samples. This plot shows the colours of Boötes field galaxies at redshift 0.3 in grey and colours synthesised from our atlas in red. The two sets of data agree well, with the only outliers being galaxy types that are too faint to be seen in the Boötes data. When we do a similar comparison using the Kinney et al. Library, we see that the colours synthesised from the Kinney et al. Templates are offset from the observed galaxy colours. These systematic errors in the prior literature could propagate through to estimates of galaxy luminosities and galaxy distances. Similar results are seen at other wavelengths, including the mid-infrared. Our templates reproduce the observed colours of galaxies, but we see significant errors when we compare colours synthesised from other template libraries from the prior literature. To summarise, we have produced an atlas of galaxy spectra spanning from the ultraviolet to the mid-infrared. Our atlas has a larger sample size, broader wavelength coverage, and smaller errors than the prior literature. Our paper is published in the Astrophysical Journal Supplement series, and our atlas is now freely available online for you to use. Thank you for your time.